I am Priyadharsini. My topic is linear variable differential transformer. LVDT is a linear variable differential transformer. LVDT is a common type of electromechanical transducer or sensor used to convert the linear motion of the object, which is a proportional electrical signal. It offers good accuracy, high resolution, good sensitivity, relatively zero mechanical friction. Construction. A typical LVDT consists of cylindrical transformer. It consists of primary coil and followed by two secondary coil and a movable soft iron core. The primary coil is placed in between the two secondary coil, and there is a soft iron core in between these primary coil and the secondary coil. And also, there is a projecting arm which is adjusted to the soft iron core. Because of this, displacement is meant to be measured. Principle of operation. When the primary coil of DC supply current flows to the primary coil, it further induces the current in the secondary coil according to the Faraday's law. Thus, the EMF generated in one of the secondary coil, EMF is generated in E1 and E2. So the net EMF is equal to E1 minus E2. It revolves opposite to each other. Working. Based on the position of the soft iron core, there will be three cases. In case 1, when the core of the center equal voltage induced in both of the secondary coil, there is a EMF of E1 and the E2 replaces as S1 and the S2. Since two coils are equal in terms but opposite in magnitude, therefore this EMF generates occasional each other. The net EMF generates will be no. This is the output of EMF E1 minus E2 equal to 0. It is also called as no position sometimes. Case 2. When the cores are left hand side, since the iron core is closer to the secondary coil as S1 and moves flexing to the S1. Thus the output of EMF of the secondary S1 is greater than the EMF of the secondary coil S2. Therefore, the net voltage of the secondary coil is positive. The output of the EMF is E1 minus E2 is positive. Case 3. When the core is on the right hand side, when the iron core is on the right hand side, from its no position, the flux linking with the coil as secondary coil as S2 is more as compared to the flux linking to the coil. Therefore, the greater EMF is generated in the coil as S2. Output of EMF is negative in this case. Therefore, we can conclude that the amount of EMF is induced in the secondary winding is proportional to the displacement of the movable iron core. The output voltage can be measured turning the relative position or the displacement of the iron core. The output voltage is a linear function of the core displacement, and the advantages: high range. It has high range of displacement measurement, no frictional losses. The accuracy of the LVDT is high output and high sensitivity. Output of the LVDT does not require any further amplification. Low hysteresis and ragged in the constructors. Limitations: sensitive to stray magnetic field. Large displacement is required. Affected by the temperature and the vibrations. Applications of LVDT can be used as the secondary transducer or sensor for measuring the force, weight, pressure, etc. Bright probing in medical applications to provide the displacement feedback box hydraulic system to measure the distance between the approaching metals during friction welding. Thank you. Have a nice day.